So at the beginning, we looked at simplifying rational expressions and determining non-permissible values. Then we got into multiplying rational expressions, and we discovered that when you multiply rational expressions, when we multiply rational expressions, what it amounts to is you're simplifying a large rational expression. Because when you multiply fractions, you multiply across the top, you multiply across the bottom. So really you get one single rational expression. By the way, to simplify a single rational expression, you factor everything completely and you cancel any factors which are common to the numerator and denominator. Then we progress to talk about dividing rational expressions, and we learned that if you're dividing rational expressions, you just multiply by the reciprocal instead of dividing by that second fraction. And that means you turn it into a multiplication, which you turn into a single rational expression, simplification. Everything we did prior to Friday funneled into factoring and canceling. And then we had to screech to a halt on Friday because when you are adding or subtracting rational expressions, it's more involved. It's more complicated. In all of these particular examples, and I'm going to pick on E, in all of these in number 1, they all have the same denominator. And I'm not going to go over my explanation of why the denominator needs to be the same again, other than to say you can add quarters and quarters and quarters, but you can't add quarters and fifths and elevenths. They need to be the same denominator. When you do combine rational expressions with the same denominator, the denominator stays the same and you add or subtract the numerators. Okay, by the way, A is not allowed to be 4 here. So if you come that far and you say, well, I know what to do, I put it together to get a squared minus a minus 12 over a minus 4, then you should notice that you have a rational expression. A squared minus a minus 12 over a minus 4 is a rational expression. And you're always expected to simplify everything in this course, which means you factor and cancel. Unless I'm mistaken, that numerator factors into a minus 4, a plus 3, and this is over a minus 4, so you can cancel those. So what if, that's question 1, what if you do not have a common denominator? Well, if you take a look at A, the lowest common denominator has to be something which contains each factor of each denominator. So the denominator of the first fraction, I'll highlight this in yellow just in case somebody's watching this, is x minus 3x plus 1. That means both of those factors have to be part of the common denominator. And then if we take a look and highlight the denominator of the second fraction, it's x plus 1. That means x plus 1 has to be part of the denominator. But when we look at what we've written, x plus 1 is already there. So what you would do then is rewrite this as 1 over x minus 3 x plus 1 minus 4 over x plus 1. And then you would say, I'm going to need to multiply the top and the bottom by whatever I need to turn it into that common denominator. And basically, you're multiplying the top and the bottom by the pieces, these are pieces, by the pieces of the denominator that are missing. So I have to multiply top and bottom by x minus 3. Now we can put them together. And we have 1 minus 4 times x minus 3. And then you simplify that. Now, before we simplify it in the traditional sense of factoring everything and then canceling, you have to multiply that top out to see what it becomes. So when I do that, I get 1 minus 4x plus 12. Negative 4 times negative 3 is 12. And I can write that top then as 13 minus 4x. And I'm done. I'm done because 13 minus 4x doesn't factor. So to review again, in question 1, the common denominator is staring you in the face. You just have to put these together and simplify. In question 3a, the common denominator is kind of staring you in the face, but you have a little bit of work to do and a little bit of thought to do. When you look at 3b, you can't just see what the common denominator is because it's not factored. So in question 3b, you have to factor this. Well, I was going to say you have to factor this part and point to something, but you have to factor everything all the time. That quadratic of x squared plus 8x minus 20, I guess I need two numbers that multiply to give negative 20 and add to give positive 8. Would be 10 and negative 2. Over here, we have x plus 2, x minus 2. I guess I don't need this anymore. So what would our lowest common denominator be in 3b? Well, it's got to contain an x plus 10. It's got to contain an x minus 2 because those two are in the first denominator. So, this one is done. We've got it in there. But it also has to contain an x plus 2, x minus 2, and well, we don't have an x plus 2 yet, but now we do. This is the common denominator. Which would mean, might as well not do this, just part way. I want on a Monday to make sure that you understand what's going on. It's been a while. That means that we are going to have to take this x minus 5 over x plus 10, x minus 2, and multiply the top and the bottom by x plus 2. Because we have to get all three in the denominator. Yes, Seamus?
How did you go from 2x plus 1 to x minus 5?
Oh, only the Lord knows. I don't know what I did there. Thank you. 2x plus 1. Thank you, Seamus. And I'm going to have to multiply the 2x plus 1 over x plus 2, x minus 2, top and bottom by, well, what am I missing? I'm missing the x plus 10. So now when you take a look at both of those expressions which we have to add together, they both have that same denominator. So we can put them together over the same denominator. The order that you write these factors of the denominator in is not important. I just want to check to make sure that that was in fact plus in between, and it was. You have to FOIL out that stuff in the numerator. And I suspect many of you, how many of you would have probably started multiplying that out at this stage when you put them together? Probably. I like writing this because some people can't. Some people, to do two steps at once is a little challenging. So now we can multiply this out. X squared minus 3x minus 10. I'm doing first outer, inner last, and my outer is 2x and my inner is negative 5x. That gives me negative 3x. Then I have plus, I guess this would be 2x squared plus 21x plus 10. Check that foiling for me. I think it's fine. Seeing some nods. You leave the bottom in factored form. So this is kind of weird. This top part here that I'm pointing at, you don't factor, you multiply it out to get it into something that can factor. And what that thing that maybe can factor is 3x squared. I have plus 18x, and I have, double check. That's kind of weird that we have negative 10 plus 10. So my immediate reaction is to check to make sure I didn't make a mistake, which should be something you learn from. You get something like that, it happens. Well, no, it's going to be 10 minus 10. So we get that, and this is over x plus 10, x minus 2, x plus 2. So I don't know that I've really said this before, but let's see where this goes. If you were to factor 3x squared plus 8x, you would take an x out, 18 I guess. We'd take a 3x out and be left with x plus 6, right? We're in agreement there? If you did that, would you be able to cancel anything? No. So sometimes what we say is, then that's good. Because really your motivation for factoring something is, at least now, to see if it cancels. I'm saying this because you may see in the textbook answers that are left that way. I would much rather see this. But again, I do understand the argument that if nothing cancels, who cares if it's factored or not? Anyway, that was a pretty extensive review. I hope that jogged your memory. Again, if the denominator is already the same, put them together and simplify. If the denominators like A are already factored, build your common denominator, convert and simplify. But if it's like B, where the denominators are not factored, you need to factor them to see the common denominator. Does anybody have any questions you would like me to go over from the practice problems? Okay, we're going to move on today and look at solving rational equations. Or solving equations that have rational expressions in them. We are going to aim for your unit exam being Friday of this week. We have this lesson, and then we have a bit of word problems to talk about tomorrow. That will give us 2 days of review. I like this idea better than coming back and having to reignite everything in your head about this, fire it up again, because you will have forgotten after 2 weeks. I will have forgotten after 2 weeks a lot of what's happened. So this is section 6.4 in your textbook. We're solving equations that have rational expressions in them, and we need to check for extraneous roots. By now, you should understand that an extraneous root is a solution to an equation that you arrive at through high quality good math, but it's still not right. So when you solve radical equations, we've learned that sometimes you get an answer that's extraneous. When you solve absolute value equations, sometimes you get an answer that's extraneous. Now you need to add into that list rational equations. So this is considered a rational equation. And let's not lose sight of the fact that when you're solving an equation, you're trying to find the value for the variable that makes it true. Well, I'm going to ask a question and ask you to think about it for 15 seconds or so. What do you suppose the first step is going to be in solving an equation that has rational expressions? That's the question. What do you think you're going to always be required to do first? And I hope that you don't need 15 seconds for that, but Who can tell me what you think you do first? Factor. You factor. You got to factor everything. You can't see what's going on mathematically until you factor. So this becomes 2. Z squared minus 4 is a difference of squares. Difference of squares. Z plus 2 times Z minus 2. And when we factor this and rewrite it, you are going to want to leave room between each rational expression in the equation. And you're not going to leave room for the same reason we left room on Friday. It's for a different reason. So I'm going to leave a bit of room here. And then we're adding 10 over 6 times Z minus 2. And this is equal to 1 over Z minus 2. So everything is factored. You want to find the lowest common denominator now. Yeah. Thank you. It should be Z plus 2. It was 6Z plus 12. When I factor 6 out, I get Z plus 2. Thank you for catching that. Now, you're going to find the lowest common denominator. I'm going to teach this to you in 2 ways. And the first way is to just figure out what the lowest common denominator is. And then I'm going to teach it to you a slightly different way. So when I take a look at the denominator of the first expression, it has factors of Z plus 2, Z minus 2, which means I need a Z plus 2, Z minus 2. And again, as I like to say, this denominator is represented now in the common denominator. It's a common denominator. That means everybody plays a role in it. It's common to everything. I hope you see why I cross my Z's. The second denominator, the denominator of the middle rational expression in this equation, is 6 times Z plus 2, which means we need a factor of 6 in our common denominator and a factor of 6 of Z plus 2 rather. Well, we already have a Z plus 2 up here, so we just need to include now a 6. And it doesn't matter where we write it. And now if I were to take a look at the second denominator, everything in there is inside of our common denominator. And the third denominator is Z minus 2, so we need a Z minus 2, but we already have a Z minus 2 because of the first denominator. Okay. Now, when we add or subtract, this is going to be something which will really throw a lot of you. Everything is going along great, and now you're going to start to mix up what we're doing today and what we were doing Friday, because they both involve denominators. When we're adding or subtracting rational expressions, there's no equals, we're just bringing stuff together and simplifying it, you convert everything to that common denominator. That's why we find it. You're not converting everything to this denominator when you're solving an equation. You're getting rid of the denominators. I'm going to multiply every piece of that equation by the common denominator. I'm going to multiply the first fraction by 6 and Z plus 2 and Z minus 2. I'm going to multiply the second one by 6 and Z plus 2 and Z minus 2. And I'm going to multiply the third one by 6 and Z plus 2 and Z rats. Not quite enough room. Minus 2. So, because this is an equation, this is important, this equal sign. If you're solving an equation, you can't miss the equal someplace. It's an equation. Because we're solving an equation that has denominators, that makes it complicated. But if I multiply everything by the lowest common denominator, look what happens. I get rid of all the denominators. I now have an equation, and I'm going to rewrite it in a second, but I have an equation that really is a early October equation in this course. It's no longer a rational equation. It is 2 times 6 plus 10 times z minus 2 is equal to 6 times z plus 2 times z minus 2. Nope. Just 6 times z plus 2. So just because, again, I use different colors, and sometimes I think that's a mistake visually, I'm going to highlight what we have left. I'm highlighting what did not cancel. Everything else is gone. And you know what? This isn't even a Math 20 problem anymore. This is a grade 9 math problem. It's not even quadratic. We can expand all this stuff out and get 12 plus 10 times z is 10z. 10 times negative 2 is negative 20 equals 6 times z plus 6 times 2. Double check that because I was on autopilot for a second there. My brain kind of started drifting, but I think that looks okay. Collect the z's on one side, so 10z minus 6z is 4z equals, what do I have? Well, 12 on the right minus 12 on the left is 0, and then I have to add that 20. So I end up with this brilliant statement, 4z equals 20. So divide both sides by 4, z is 5. And that is our answer. But we need to check it because you could have extraneous roots. And then I'm going to explain to you how you can bypass that whole check thing with these questions. I'm going to go back to the original equation. There it is. You will notice, by the way, in your notes, it says if you need a further similar example to this, you can go to your textbook. And on page 342, example 1 will do it. I go back to the original equation. Just going to make a bit of room here. And I want to take a look at the left side and the right side when x is, what did we say, 5? So when x is 5, I will have 2 over 5 squared minus 4 plus 10 over 6 times 5 plus 12. And on the right side, I have 1 over 5 minus 2. So I've just replaced the z with my solution that I believe is correct. Everybody needs to lean on their calculator every now and then. I'm going to get 2 over 21 for the first. 5 squared is 25, minus 4 is 21. Plus 10 over, I guess, 42. 6 times 5 is 30, plus 12 is 42. I get this number. When I take a look at the right-hand side, 1 divided by 5 minus 2. 5 minus 2 is 3. You get the same answer. So it's correct. Does anybody want to take a stab as to how you would get an extraneous root? Maybe that's not the best way to put it. If you got an answer here and it was extraneous, what might that answer have been? Seamus? No, not 0. Yep. No. Say again? 2 would be extraneous. Negative 2 would be extraneous because they're non-permissible values. Is that what you were going to say? If you get an answer, you don't have to do what I've got in the top right-hand screen here. If you get an answer, all you need to do in this section is make sure that it's an allowable value for x. You don't have to worry about subdomains or anything complicated. As long as there wasn't an x minus 5 in the original equation, in the denominator, then 5 is good. All right, let's try one more. So 3x over x plus 2 minus 5 over x minus 3 is equal to negative 25 over x squared minus x minus 6. We have to factor everything to see what the, oh, I'm sorry. I told you I would show you a different way to do this. And it turns out it's not really a different way, it's just a different way to think about it. And this is how I was taught. And to me, it makes sense. But, you know, that's just me. Somebody else might be different. Let me go back to the point in time where we had factored everything. So I hadn't yet multiplied top and bottom by anything. I hadn't canceled. I hadn't highlighted anything. We were here. All right. So, and I think if you do it this way, you're less likely to mix up what we were doing Friday with what we're doing today. Because, just to recap, on Friday, you found a common denominator to change everything to that common denominator. But today, we're finding it to eliminate the denominators. So here's how I was taught. And I love this. I think it's brilliant. Do we want denominators? No. So, man, I got a z plus 2 there. I'm going to multiply that by z plus 2 to cancel it. But that means I need to multiply this by z plus 2 and this by z plus 2. Okay, will I have eliminated this z plus 2? Yeah. And, oh, as an added bonus, I will have eliminated that. But I've got a z minus 2 that's still there, so I have to multiply everything by z minus 2. I hope you see where this is going. It's going to be the same thing we're multiplying by. It's just the thought approach is different. So now I go, oh yeah, finally, I have cleared the denominators from my first rational expression. Oh, and as an added bonus, I've cleared the denominator there. But, oh man, I still have a denominator someplace. I have a 6. Well, then I'm going to multiply both sides, which means each of these pieces by 6. And you end up with the same result. This might even be a way for you to imagine how you get a common denominator. Anyway, just a slightly different approach. So let's rewrite this in factored form. 3x over x plus 2. You want to space things out. Minus 5 over x minus 3. This is equal to negative 25 over x minus 3, x plus 2. I think, isn't that factored correctly? Don't make me do all the work. You guys should be thinking as well. Okay. So, if you took the second approach that I just finished talking about, you would say that to get rid of the x plus 2, I need to multiply everything by x plus 2. But then you would say, that will not get rid of the x minus 3, so I need to multiply everything by x minus 3 as well. Or you could say, the lowest common denominator has to contain x plus 2 because there's an x plus 2 in the denominator of the first expression. The lowest common denominator has to contain an x minus 3. And now it does. The lowest common denominator has to contain an x plus 2 and an x minus 3 because of the third piece of the equation, but it already does. So regardless, you multiply everything by that pair of factors. I don't think you really need the brackets around the x plus 2 on the bottom and the x plus minus 3 on the bottom, but I'm just driving the point home. Cancel, 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 cancel. So, what do we have left? We have 3x times x minus 3 minus 5 times x plus 2 equals negative 25. And this particular question is a Math 20-1 question because it's going to be quadratic. Do me a favor and expand this out and zero the equation. I'm going to get 3x squared minus 9x. I'm going to have minus 5x minus 10. Fatal flaw there if you forgot to carry that negative with the 5 through. Negative 5 times 2 is negative 10. I don't think it's unreasonable to say we know it's quadratic, so we're going to have to zero the equation. Why don't we move that 25 over right now? You could certainly move it over later, but when you solve a quadratic equation, it needs to be zeroed. So I'm getting 3x squared minus 14x plus 15 is equal to 0. I want to double check all of that. I have minus 9x and minus 5x, which is minus 14x. I have negative 10 plus 25, which is 15. Yes? I think so. Oh boy, is it factorable? Do the old b squared minus 4ac trick. It's factorable. If you're wondering why I didn't put negative 14 quantity squared, because it's b squared and b is negative 14, it's because I know when I square it, it's going to become positive anyway. So I didn't waste my time entering brackets, although I wasted more time explaining why I didn't enter negative 14. 16 is a perfect square. Again, I think you guys are getting to know me quite well. Just because it's factorable doesn't mean I'm happy about having to factor it. I'm not good at factoring stuff like this. I'm really not. If I were working on my own, I'd probably just use the quadratic formula. I don't know. There's a little piece of my brain that's, I was going to say damaged, but it's not damaged. It's just was never working right to begin with, I suppose. So I'm guessing it's 3 and 5, and if it's 3 and 5, the 3 better go away from the other 3. Oh, look at that. First try. I think that's correct. My outer is negative 9x. My inner is negative 5x, which gives me negative 14x. All right, so that means 3x minus 5 equals 0, or x minus 3 equals 0. Solve this little linear equation and you get 5/3. Solve this and you get 3. So those are our answers. X equals 5/3 and x equals 3. Any questions? Come on, you guys. Seamus?
Like about the whole thing or just the getting the roots?
Anything.
Wouldn't x equals 3 be an extraneous root?
X equals 3 is extraneous. Yeah, perfect. Because there's an x, I think, isn't there an x minus 3 as a denominator factor in the original expression? That's excellent. You have to watch out for that. What we're really looking at when we're talking about extraneous roots here with these rational equations is we're really talking about NPVs, non-permissible values. X is not allowed to be 3 or negative 2 because of the factors in the denominator. So you have to kind of keep one eye half peeled looking at those numbers when you get a solution. So x equals 3 is extraneous, which means it's stricken from the list. If you had to explain this on an exam, you would probably say, well, it's a non-permissible value. It's not in the domain of real numbers that we're allowed to use. You could say a lot of things. Any other questions about this or comments about this one? All right. So very similar lesson to Friday in that there's not a lot of work here in the lesson. The work is going to be you practicing, flexing those muscles and getting them a little bit more in tune to the math. I think it's pretty clear that the lowest common denominator is the product of these two denominators. It's the product of 2x minus 1 and x minus 2. I guess we can make a note right now. X is not allowed to be 2. X is not allowed to be 1/2 by looking at those two denominators. Thank you. I take it you were going to ask me where the equal sign was or where it went? Yeah. So since the lowest common denominator is the product of those two things, we are going to multiply all three of these pieces by those two factors. And again, our motivation here is not to convert everything to those denominators. Our motivation is to get rid of the denominators. You know what this is like? It's like cross multiplication, except you've got more than two things. You've got 3 or 4 or 5. 2x minus 1 cancels here, and we're left with 12 times x minus 2. This is equal to what happens here. The x minus 2's cancel, and we're left with 2 times 2x minus 1. And over here, nothing cancels. You're left with that. Feel free anywhere along the way when you're doing this on your own to multiply this stuff out. If I were doing it on my own, I probably would have just written 12x minus 24, 4x minus 2, and I probably would have FOILed out the x minus 2 and the 2x minus 1. Let me double check that. I think it's okay. Look, you have these three things that you need to multiply together. And when you multiply three things, you pick two of them and multiply them and then multiply by the third. I'm just not a fan of multiplying the 5 by the binomial and then having to FOIL out bigger numbers. I think it's better this way. How's it look? So 12x minus 24 equals 4x minus 2. I can't remember. I'm mixing up my classes now, but I'm pretty sure I've told you before, and if I haven't, that's fine. I'm telling you now. We're getting into an area where when you do algebra, each step should be done twice. Like you do the step, and then you look and just double check everything. Because there's a lot of stuff going on. This was 5x squared plus 25x minus 10. This negative 5 has to be multiplied by everything. So double check everything. Yeah, it looks okay. We in agreement? Wow, yeah. This should be 2x squared, shouldn't it? Which means, so let me just back up here. x times 2x is 2x squared. I'm still going to get minus 5x in the middle. I'll have negative 4x and negative x, and it's still going to be plus 2. Thank you for catching that. So I get minus 10x squared plus 25x minus 10. Now I'll triple check those. 2x squared minus 5x plus 2. I'm multiplying by negative 5, which gives me negative 10x squared. It gives me positive 25x. It gives me negative 10. I think I'm back on track now. It's quadratic, so we better zero this equation. I don't like negative x squared, so I'll move the x squareds to the left side where they become positive. What do I have here? 12 minus 4 is 8. Minus 25. I think I'm going to get negative 17. You're going to double check that, and I'm going to double check it in a second. And then I have negative 24. I'm going to add 2, and I'm going to add 10. And get negative 12. So 10x squared, 12x minus 4x is 8x, 8x minus 25x is negative 17x. That looks good. 24 plus 12 is negative 12. Negative 24 plus 12 is negative 12. I think it looks okay. Yay, nay? Good. I'd be surprised if this is factorable, although I just don't like big numbers, that's all. Let's do b squared, 17 squared, minus 4 times 10 times negative 12. Again, I'm not putting negative 17 squared because I know when I square it, I will get the same thing, whether I put the negative or not. So negative 17 squared minus 4 times 10 times 12. I'm pretty sure that's a perfect square. Nope, it's not. So that means that we have to use the quadratic formula, which is part of this course, right? The nice thing about that, everybody, is since the non-permissible values were 2.5, and we have to use the quadratic formula, whatever we get will be correct. Because we're not going to get 2 out of the quadratic formula, or a half. So the quadratic formula, it's been a while. I'll write it out for you. Was that number 769? Is 769 divisible by 9? You've already checked. What else could it be divisible as a perfect square? I don't think anything. Does 3 go into it, by the way? No. It might even be a prime number, which would be kind of weird. Anyway, I don't think we're going to have to worry about simplifying this radical. We're going to get x equals 17 plus or minus root 769 all over 2a, which is 20. That's it. That's the answer. In many ways, much simpler to get the answer with the quadratic formula. That's it. We don't have to simplify it at all or do anything to it. That's weird. It's a prime number. Just for curiosity's sake. I was just curious if anything divided into it. That's another weakness of mine, is figuring out how to factor bigger numbers. So sometimes I just go to Wolfram Alpha. All right. On page 348, 2, 3, 4, and 6 are practice problems. Factor. Get rid of the denominators by multiplying everything by the common factor. and then use your mathematical skills that you've learned elsewhere prior to today to solve the equation. Don't forget to keep your eyes peeled for non-permissible values. I have a couple of quick things to do at my computer, then I'll come around and check on your progress here. You got about a half hour today of class time to work on this.